In this segment, we'll look at library-based implementation of variadic functions, which is much more orderly and portable than the handcrafted pointer manipulation we did earlier. As discussed in the prior segment, retrieving variadic parameters in a variadic function requires delicate pointer arithmetic. And even worse, the exact arithmetic required depends on the layout of the RTS stack frames, which differs per compiler and machine. So, in principle, you'd need to rewrite code like our example variadic.c for each different compiler and machine. Now, the solution is to abstract the process of traversing the variadic parameters into a library, the system standardarg.h library in particular. Standardarg.h supplies standard macros for variadic parameter retrieval. Each compiler and target machine gets its own version of standardarg.h, which has macros implemented appropriately for the RTS in question. Let's illustrate these macros by walking through an implementation of a simplified printf function. The alt.printf function here is variadic, as you can see on line 4. Its format string allows format specifiers %c, %u, and %s, and that's it. And alt.printf retrieves for each of those, respectively, a variadic int, or char star parameter to print out. Recall, by the way, that %c expects an int parameter. Now, the function first declares on line 5 a pointer to walk through the variadic parameters. The standardarg.h macro va_list substitutes into the right type for such a pointer. This is probably a char star or a void star. So va lists params might expand, for instance, to void star params. Thus, but it may be a different type if the standardarg.h author wanted it to be. We just trust it to be correct. We'll put a question mark there because we're not really sure. The line 6 va start macro, and it's not a function call, it's a macro, expands to an appropriate initialization of params. And again, this is likely to be something like, maybe params equals address of format, and make that a character pointer, and add 1 to skip past the format character pointer. And so that's one possible implementation anyway. And again, the implementation is abstracted by the macro. We just trust the macro to expand it to the right initialization. Now, in alt.printf's main loop, and we'll have more on the logic of that in a bit here, we retrieve the next variadic parameter by macro calls like vararg params int, here as on line 14. Now, this expands to the right expression to both dereference params to get an int, and also to advance params by the size of an int preparatory to the next vararg call for whatever follows the int. And so here's question 1 for you. Now, assuming that params is char star, let's say, instead of void star, so it will increment properly, and assuming that it's pointing to a variadic int parameter, write an expression that both returns the int to which params points and advances params to the address just after the int. You should find that you need pointer casts for that. And coming back from a pause, one way to do that would be to have first an incrementation of params by size of int, and then that will not be the right address we need. So what we will do is take it as an expression, subtract from that size of int. No one said these macros were pretty. And that will then be the right value with params having been incremented along the way. So we take that whole shebang, and we're going to need to cast it to an int star because it would otherwise be a char pointer. And then we dereference that to actually get what's pointed to. So if you can follow all that, that would work. And break it to the next line for readability there. Okay, so Finally, the line 41 macro call, all the way down here, call of VA end on params. This does any cleanup that's necessary after all the variadic parameters are retrieved by VARG calls. Now this is rarely needed, so in most standard arg.h implementations, line 41 would expand to nothing at all. But the macro call is there, just in case, and you should always include it. And that's about it for the standard arg.h library. You declare a VA list variable, you initialize it with VA start, you iterate and retrieve variadic parameters with VARG, and you wrap it up with a VA end call. And your code works under all compilers and machines. And here's question 2 for you. Why are all of these macros? Why couldn't macros VA start and VARG VA end be functions instead? There are at least 2 good reasons. See if you can come up with both. So coming back from a pause, first, if they are functions, they'll need to be passed the VA list by reference, requiring an awkward ampersand, since they modify VA list, and the library designers wanted to abstract that away. Also, VARG in particular must return a different type on different calls. There's one here for an int, there's one down there for a char star. We'll look more at that in a minute. Now, it must also accept a type as one of its parameters. That's int, a keyword, not a variable. So no function could do that, both return a different type each time and take a type as an argument. It'd have to be a macro. Now, the alt-printf logic itself is not essential to this discussion, but it leads to an upcoming look at the standard io.h library, and we should review it for completeness, so let's do that. The lines 10 through 40 loop here iterate through, or iterates, that loop iterates through the format string, one character at a time. And as you can see, it tests to see if the character is a percent. We'll look at that case in a moment, but if it's not a percent, then we go to the else branch on line 38, which is the simple case, and that just prints the format character back out to standard output as printf is supposed to do. And by the way, all printf output, or alt-printf output, is done by putchar. So any non-format specifier content in the format string just gets printed directly. The format specifier handling is the more interesting case. The line 12 switch up here advances format to the character after the percent sign and then switches on that character. So if it's a C, then we get the branch here on line 14. We were already looking at that earlier. It prints out the ASCII code in the int variadic parameter that is expected to be there. Remember that putchar accepts an int parameter, expecting it to contain an ASCII code. Now, if the format character, on the other hand, is a U down here, then line 17 copies the variadic parameter into value, an unsigned int is expected, and then lines 18 through 22 convert value into a series of decimal digits, assigning them from right to left, from the least to the most significant, into array ival in this loop here, and then printing them back out from left to right down here. Now read lines 18 through 25 carefully and answer these questions. Question 3. First of all, why shouldn't we just do a putchar value? Putchar accepts an int, I just said so. So we just do a putchar value here, wouldn't we? And then coming back from a pause, well, no, wait a minute. Value is a binary integer. It's not an ASCII code here, not with a %u format specifier. So if, say, value is 123, we want to print 1, 2, 3. We don't want to print opening curly brace, which is, as it turns out, the character with ASCII code 123. So we do need to convert to numerical form. Question 4, though, why are we adding a 0 to value %10 on line 20 here? And then also, just another question to toss onto the list here, what if value doesn't need all 10 bits of or 10 bytes of ival? You notice it is a 10-character long string. If we don't use all of those, if this loop ends earlier, will we wind up printing garbage? So again, pause and think about those, just to make sure you have the logic here straight and you've thought it through. And the answer is that, first of all, value %10 yields the numerical value of the lowest digit in value. And adding "0" gives the ASCII code for the digit that represents that value. And since lines 24 through 25 iterate forward from index, not from 0, then any unused characters at the start of ival will not be printed, and there'll be no garbage print problem. And then finally, closing up here, lines 28 through 30 cover the %s case. They retrieve a char star variadic parameter, and then they traverse the string to which it points, printing said string character by character. And by the way, the default case simply prints any unrecognized format specifier literally, including the %. So, final point here, except as an exercise, you should not hand traverse the RTS with pointers like variadic.c did. In professional code, implement any variadic function using standardarg.h.